Can you define population for this question 5? What is the population of interest, Hafiz?
Population
Yes, Hafiz?
cereal plastic packet.
Okay, maybe Hafiz is not. Okay. Kavan?
The number of plastic bags produced in the factory.
Hey, Kavan, you make the same mistake already. You make the same mistake again. Can you say number?
Total.
Huh? Can you say number? Can you say number? That's why I say, you see or not, you until now still don't know how to define. So population, that means I'm talking about packets of cereal packed by this particular machine, correct? Okay, what is the parameter of interest here? What are you trying to predict? That means we are talking about the variable. What is the parameter of interest here? The variable. Yes, Thaddeus? You want to know the mean weight of packets of cereals packed by this machine, correct? You have to define it clearly. You want to, or if you want to say the variable interest, you want to predict the mean weight. For this case, we can say predict the mean weight of packets of cereal packed by this machine. So how are you going to justify this? How are you going to do this prediction? How are you going to do this prediction? You are going to use sample mean weight of packets of cereal packed by this machine. You see, I purposely. Okay, now. So, what is the sample size that is used here? What is the sample size that is used here? Hao Shen, what is the sample size for this question? Hao Shen?
Is it 75 packets?
Hao Shen, I'm asking Hao Shen. Okay, class. Okay, Hao Shen, what is the sample size for this question 5?
75. 75.
75. Kiko, is this sample size large enough to assume that the sample mean distribution is normally distributed?
Yeah. It is because it is greater than 30.
Louder, please.
It is greater than 30, so it is.
So you must say according to central limit theorem, the sample size
n
equal
equals
to
75,
75.
which is greater than 30, so it is normally
The-
distributed.
So we can assume that the sample mean distribution is normally distributed. So if it's normally distributed, then can we use the formula to predict? The answer is a yes. But this time, we want to construct the 90% confidence level, correct? Confidence interval. We want to construct a 90% confidence interval. Okay. Siti, can you explain what do you mean by 90% confidence level?
90 of 100 sample will lie between the confidence interval.
Louder, louder. We can't hear you. Siti?
90 samples out of 100 samples contain population mean.
It means that if we take 100 samples, 99 samples that is used to 90 samples that is used to predict the true population mean will capture the population mean, correct? Okay, so now if the 90% confidence level interval, so what is the Z alpha over 2? What is the Z alpha over 2? Sarafina? What is the value of the Z alpha over 2? They in the exam, they can ask you, they can give you this formula. They can ask you what is the value of the Z alpha over 2 in this case. So you have to know. Cindy, what is the Z alpha over 2? Cindy, answer me. Sarafina, you are not answering me. I call you third time already.
$1.64.
Yes. How do you get that, Sarafina? How do you get 1.64?
Inverse norm.
Can you repeat again? Sarafina?
Yes, inverse norm.
Yeah, inverse norm. Please tell me exactly what I supposed to key in.
Inverse norm, then 0.901 center.
Then center. I tell you what, all this you have to know how to get. Okay, so now, thanks. Okay, may I know what is the value of the standard deviation for this case? What is the value of the standard deviation for this case?
14.9.
14.9. So in this case, when you use the standard deviation as 14.9, what must you do? Do you have the population standard deviation? No. So you have to assume that the population, this sample standard deviation is the population standard deviation, correct? You make the assumption. Okay. So we know N, we know this. Okay. May I know what is the X bar here? Yeah. Safwan, what is the X bar here?
Upper limit.
Yes.
Upper limit.
What is the X bar here that we use to predict?
Margin of error.
513.8 gram, correct? So you won't be surprised during the exam. Okay, you can use a calculator, but during the exam, they also can write down the formula and ask you what is each and every one of them means. You have to be very careful because statistics is like that. They can write the formula and ask you, what does it mean? They can even put that 1.64. Then they ask you, what is the confidence level that we use? It doesn't mean that all questions I have to give you the confidence level. I can write down the formula for you, and with the number there, you have to know what is the confidence level. That means if I put 1.64, you have to go to normal CDF. Correct? Normal CDF, lower boundary, negative 1.64, upper boundary, 1.6401, and you get the probability. And that will be your confidence level. That's why when you all do a question, when you all study all this, you have to know. People can ask you from the reverse way. Are you clear? Okay, good. So you can substitute in and you can get the confidence interval. Yep. Okay, now if you use your GC. Okay, if you use your GC, okay. Cindy, tell me what to do. If I want to use my GC, what to do? First, what button must you press? Yes? Stack. Which one must you select? Test. Then 7. There is Z interval. Okay, what's come out? What are the things that you're supposed to key in? Sure. Let me check first. Okay, I go stack, I go test, I go 7. Okay, input first. Input. Input, you must select stack. All right? Hello? Okay, then this one, what must you put in? Ah, 14.9. Then X bar, you must put in 513.8. Then N is 75. Then confidence level, you put 0.9. Correct? Then you calculate, you get the answer. Okay? Okay, what happened? Okay, huh? So understand? It's okay, slowly. Okay, so now, before we go to the next one, huh? Nicholas, write
Yes,
this
miss.
confidence interval in word. We are,
We are 95% confident.
where got 95% in this case?
Or we are 90%. 90%
We are
confident.
90% confidence that
The true population mean weight of cereal can go
of
as
packets of cereal
can go as low as 511 grams and highest 517 grams.
Yeah. So this is your 90% confidence interval. So we can say that we are 90% confidence that the true predicted population mean weight of packets of cereal packed by this machine can be as low as 511 gram or as high as 517 gram. Okay, clear? Okay, so now why we need to count confidence interval? The reason why we want to make a prediction of a true population mean based on a sample mean is because we want to justify some claim. Okay, so now I'm going to give you a claim. Then you use this to justify it. Worry. So in this case, we have insufficient evidence to reject Mr. K claims because the mean weight of 515 gram is possible to happen because it lies within the confidence interval. Get me? It lies within the confidence interval. Or if you don't want to say lies within the confidence interval, you can say 515 is greater than 511 and is less than 517. I'm referring to these two values. Can I not? So for this claim, it will be insufficient evidence to reject. Okay, now, but yesterday, why is a different story. So you have to look at the claim. Very important. If I change this claim to become then this will be a different story. Correct? Am I right? So if I change the claim to become this, the one in red, then I will say, we have sufficient evidence to reject. Mr. K claims that the mean weight of a packet of cereal packed by this machine is more than 515 grams because the possible predicted population mean weight of packets of cereal packed by this machine can be as low as 511 gram, which is less than 515 gram. So I reject the claim. You see or not? So my advice is, if you look at the book later on, they will always say within the confidence interval, outside the confidence interval. Try to not to say outside the confidence interval because it depends on the situation. Are you clear? If I have another situation, a customer claimed that the mean weight of packet of cereal packed by this machine is less than 515 grams. So I will say that I have sufficient evidence to I have sufficient evidence to reject the claim because the mean weight can go as high as 517 grams, which is more than 515. You see or not? Hello? So depend on the claim, how you want to justify the claim. Are you okay? So I'm trying to, okay, every question you go through, you must ask yourself, what is the population of interest? And how should you do it? Okay? So I want everyone to have a clear idea. So you try to do the rest. Okay, so I want to go to sample size, suitable sample size. Okay, yesterday we said the width. So I write down the formula again, the predicted. This is predicted true population mean. So what's our mean? You have to specify it clearly for the situation. X bar n plus Z alpha over 2 standard deviation of the sample or standard deviation of the population divided by square root of n. Here will be so therefore W is the width. Okay, the width. So the width will be equal to 2 times the margin of error. All right, yesterday we talked about 2 times the margin of error. This is called margin of error, correct? And if you go back and do it, you will have your n is equal to how is the formula like? You bring over the whole thing square. Okay, go. Yeah. So it will be 2 times of Z alpha over 2 times by the standard deviation divided by the width. All right? Okay. So now, the purpose of this is, if I want certain width, what should the sample size be? What is the minimum sample size that you must take? You use this formula to find. Are you clear? Are you clear? You use that formula to find. So this is a very important formula you must jot down. Okay, can you please look at example 8? On page 275. Okay, in example 6, we consider the population of yabbies whose weight had population standard deviation of 16.8 grams. Okay, what sample size is required to find a 95% confidence interval for the mean weight with width of 5 grams? That means the confidence interval that I want to find, the width is 5 gram. Are you clear? So you straight away apply this formula. 2, 1.96. What is the standard deviation for that one? 16.8. And the width is 5. And remember to square it. This is a very important formula. It can cost you 3 marks. Okay, so what is your answer? Okay, 173.5. Okay, I want you to listen here carefully. In this case, you must answer like that. The sample size must be at least 174. You must always round up. If you didn't, then the width will not be 5 grams. Do you get me? Always write in the form like that, then you know you have to round up. For example, if I get 173.2, even I get 173.01, I still have to round up. Because if I round down, the width will not be 5 grams. It will be more than 5 grams. Because we know that the lower the sample size, the bigger the spread. So this is a very important. Instead of say the sample size of 174 yabbies is required, you say the sample size of the number of yabbies must be at least 174. So the word at least there give you the sense it must be more than that. The minimum value. Always round up. Do you get me? Okay, now, in this question, they give you the width is 5 grams. Johan, I'm not talking about the claim. I'm talking about how to find a suitable sample size to get this width. Okay. They say
actually,
width
that claim
equal to
was
5.
to the earlier question. Sorry.
Instead of the width, I will say that what sample size is required to find a 95% confidence interval for the mean weight that is within 2.5 grams. When I say within, it means that this is your sample mean, the middle. Here, higher goal is 2.5, lowest minus 2.5. So that means the width here will be 5 grams. That is the meaning of within. So be very careful. Be very careful of the word that we use. Very careful. Read carefully. So I can also say that instead of giving you the width, instead of telling you is within, I can also say that the width is the Width is the what? I can also give you the margin of error. Which part is the margin of error? Yeah. I want the margin of error to be 2.5 gram. So that means within and margin of error means the same thing. Are you clear? Be very careful. I can use different words. I can say with the margin of error of 2.5 gram. Are you okay? So all these are the important things. Okay, so on that note, you should be able to do exercise 9.2, and actually you can also do 9.3. I teach you how to justify the claim reading. Am I right? Okay. So what is important here is, if you are talking about true population mean, you want to predict true population mean, this is a formula, and you want to find a suitable sample size, a minimum sample size with a certain requirement of the margin of error or the width, then you have to use the second formula. So these two formula is a must for you to write down in your notes. And please write a few examples of how to justify a claim based on the three different claims. I've given you the 3 different claims, all right? And how to use your graphic calculator to find the confidence interval for true population mean. Hello, those online, these are very, very important. Okay, any further question?